In this video we are going to create a road with MDT, from a previously designed horizontal alignment. We start by generating the superelevation file from the horizontal alignment, using the command with this name. We select the category of the road and leave the other parameters by default. We write the name of the superelevation file and accept. Now we check the superelevations graphically and check that everything is correct. Now let's get the longitudinal profile. We select the horizontal alignment and keep the default parameters. Then we draw the profile with a 2 format in model space. We note that it has automatically created 2 sheets. We continue with the obtaining cross-sections. We indicate 25 meters as the length of each profile to the left and right of the alignment. We will also draw them in DIN A2 format, but this time in paper space, at 500 scale. We check that a presentation has been created for each sheet. The next step is the definition of the vertical alignment, which in this case we are going to introduce manually. We execute the command to enter vertical alignment, create a new file and type the station and elevation data of each vertex. We are now going to introduce vertical curves. To do this we select the line of the second vertex and double-click. We can define the curve in several ways. In this case we enter the parameter of the parabola and see that the rest of the data is calculated. We repeat the process with the third vertex and accept. We now begin to define the type section of the road. We run the command and see that a library of sections is displayed. We chose the urban section with 2 lanes and press accept. We select the alignment and a dialog is displayed, organized with a series of tabs. In the Platforms tab, we press the button to add a new one and accept the final station. The graph shows the vectors of the platform in yellow and a simulation of the natural terrain in green, with clearing on the left and embankment on the right. Our intention is to define a road, in which the first 200 meters does not have a sidewall. K and then continues a sidewalk with its curb until the end of the alignment. That's why we added a new line to the platform assignments and introduced the station 200. Now we delete the vectors of the sidewalk and curb with the delete key. Since MDT interpolates by default between the stations of different platform assignments, in this situation we will be interested in directly entering the station 200, the sidewalk already defined in the final station. To do this, we select the final station and press the duplicate button. Now it is necessary to change the behavior of the superelevation for certain elements. To do this, if we position the button on the header of any vector and press the right button, we have several options. We leave as active only lane 1, lane 2 and exterior shoulder and disable the rest. In pink, the active vectors are represented. Once the platform is defined, we see that we really only need one lane on each side instead of the two that appear. To eliminate the excess lanes, we place the cursor over the lane 2 column and run the delete option. To define the roadbed, activate the corresponding tab and press the insert button, adding an assignment until the last station. Now we change the thickness of the roadbed to the value of 1 meter. The criterion, we change it to slope to assign a constant value to the slope of the vector from the alignment. For the definition of the ditch, we activate the tab and press the insert button. In this case we are going to use the number 1 ditch. But we are going to add one more vector. Press the insert next button and assign the new vector the values for the increments on the x and y axes. Now it asks us for the station until which we are going to make the assignment. We activate the assignment by intervals box and set as initial station 100 and final station 200. It can be observed how the ditch appears drawn according to the indicated characteristics. To define the cut slopes, activate the cut tab and press the insert button. Then a window appears where you select the slope to insert, which in this case is a fixed slope with slope 1.5. We indicate that the assignment will be made until the final station. For fill slopes we will proceed in the same way, only in this case the value of the inclination is different. Now we activate the plan view, which allows us to visualize how the defined road would look. In this case we have placed ourselves in the station 200, which is represented by a yellow line. Click OK to exit the section definition. Finally we will define the widenings associated with the road that we are defining. To do this way, execute the command generate widenings. It asks us for the table and automatically generates a widenings file according to the selected road category. We can view the information of the widenings, and for this we execute the command list of widenings selecting the file generated previously. Once we have defined our entire type section and the rest of the elements that make up the vial, we can group them so that from this moment we work with a single file that includes them all. To do this we create a new segment file. Then press the auto button and all the linked files are automatically imported. Now we can fully represent the project profiles. In the menu we choose the command drop profile and select the segment file. We define the horizontal and vertical scale values, the labeling interval and the continuous format. Press the OK button and specify an insertion point for the drawing. After drawing the profile, you have detected an error in the parameters of the vertical curve of the vertical alignment. To correct it, we execute the vertical agreement command and designate the vertex of the vertical alignment. We change the value of the parameter and press the Enter key so that the rest of the values are recalculated. When validating the dialog and confirming, we observe how the drawing is automatically updated. We answer yes to the question about whether we want to update the associated segment. To draw the cross-sections of the projectway, execute the command Draw Cross-Sections and select the file of the segment. This time we select as DIN A0 paper format, horizontal and vertical scales 500 and draw in model space. Click OK and draw as many sheets as necessary to represent all the cross-sections. We observe that the drawing includes the existing ground, grade line and roadbed, with the labeling of areas and elevations for each profile.